Well, good afternoon, good morning, good evening. Not exactly sure when you're taking a look at this, most likely in the afternoon. Wanted to explore a little bit about word problems. Now, we've taken a look at fractions, we've taken a look at decimals, and word problems are another area that struggling learners and those with disabilities really have difficulty with. And it really goes back to what we know about struggling learners, and that is reading. 20 years ago, the primary concern for individuals with learning disabilities and a lot of the struggling learners that would seen as high functioning in respect to disability areas or high incidence, well, reading's their number one. About 20 years ago, writing was number two. And I think we explored this a little bit in earlier presentations. But over the last 10 to 15 years, we've gone from reading and writing to reading and math. And a lot has to do with the language. And word problems are a perfect example. But a lot more math is language orientated as well. And let's get off this example here. But what we need to remember is that the language element of what individuals are struggling with is everything from reading the word problem, understanding the phrases, not being able to identify the clues that we've put in there in respect to translating that over to a phrase or translating it over to a number sentence or translating it over to an equation. This is challenging. I'll throw one additional challenge in, and I'd argue that second sentence, she spends 1 hour at the store, and we'll worry about buying 3 more pencils later on. But that one, where does it go? How do I use it? And we get into more complexity of word problems. Oftentimes, that's another challenge for the individual, is being able to pull that information out. So what I want to do today is explore a little bit about some strategies that we know work and set us up a little bit for the technology that I want you to explore as we go forward. Now, this is a bit humorous. I found this on the internet, but there are elements that are some truth for individuals with disabilities and those that struggle. So for example, if at all possible, avoid reading the problem. And I know we have some learners that do that. They just look at the numbers or they extract the numbers from the problem in order they appear. Bingo, we're ready to go. Or if, rule 2 yields 3 or more numbers, well, we'll just go, we'll put them all together. All the way down to if the rules 1 through 6 don't seem to work, make one desperate last attempt. And yes, it's a bit of kidding, but it's amazing how I've seen individuals approach word problems. The lack of strategies, the lack of understanding, the lack of understanding of key terms, so many things that I guess we take for granted with typically developing individuals and how they would take what they can generalize from one area to another and make the connections over to the operations and equations. We can't do the same for individuals that struggle. Now, one of the primary areas has to do with the key terms. And what we find is that many children, especially those that struggle and those with disabilities, they don't know how to truly understand the question that's being asked. So when they're trying to figure out the correct operation, they don't understand the key words. Now, oftentimes, we offer clues, and those clues, in terms of our typical developing in terms of our readers and individuals that have been exposed to the essential elements of math, they're able to take some of those terminology and apply it. And maybe there's a struggle now and then, but for our learners, it's very purposeful in the fact that they need explicit, direct instruction on this terminology. And honestly, this terminology needs to be consistent. But the more and more math problems I look and the more math books I look at, and the more IXL and other problems I see is I don't see a consistency of language. Now, they may not use the laundry list of terms here, but there's a lack of consistency of language. And that becomes a major challenge. So one of it is we need to tackle that. We need to be aware of what the language is actually offering, explicitly teach the individual those things, prompt those things for them to understand that these are key terms, just like we do in reading. When we work with struggling learner with reading, we help them, we scaffold them, we support them, we offer them strategies. We need to do the same with keywords with math. Another aspect that's critical is visualization. What a surprise! We've been talking about visualization with fractions and decimals. Yes, we have. The same thing goes along with the word problem. Now, one of the things that is highly recommended, especially as the individuals initially exploring, but I would argue as you continue to explore word problems, draw out the problem. That way they can see it, they can make it less abstract, they can make the connections to the equations that are going to follow. And if this is a problem for individuals that we're working with, this is something that's worth the time. And there's a number of technologies that allow us to do it. And yes, it may take some time initially, but if they can, again, begin to see the problem, begin to make it less abstract, when we get the problems become more complex, they'll be able to make the connections. Here's a brief example. pulled this one out of a study I was reading not too long ago. And then simply, we have Tanya. She's basically grabbing out the clouds. And as you can see, by her order and numbering the clouds, she's going to come to 8. Now, as we get more complex, actually for an individual, we may not want to number the clouds. We may just want to simply, each cloud is a cloud. And then, of course, you can do the addition, subtraction, multiplication, etc. from there. But in this instance, she numbered them. So therefore, across the actual identification per day, there she goes. Now, we're going to talk about tabling or organizing data and drawing out data later on with schemas, but we'll wait for that in terms of another activity. Here's another example in terms of the fact that not only have we identified what we're trying to do, but we've also visualized it as well. But notice we've also underlined. And that's a simple strategy, but oftentimes, what do we underline? I think back in terms of struggling readers, what do we highlight? I'm here at a college campus, and I'll go into a college bookstore. I haven't been in there in a while looking at used books, but I know several years ago looking at the used books, you'd pick up some and they're just about as yellow as you can get in terms of the highlighter. Well, what's purposeful in terms of highlight? What to really identify that's really important. And the same thing goes for math word problems, teaching them what's important, what's not important, and then being able to adjust from there. And drawing out it helps for individuals. Now, we need to be aware the problem type. We talked about this with fractions. We've talked about this with decimals, word problems as well. We know that there's basically 5 basic elements of what we're looking at with word problems. We have the part whole, right? A word problem with a whole is composed of 2 parts. We've talked about that with fractions and decimals. Join, a word problem that 2 quantities are combined. Well, there you go. And combine, what does combine mean in terms of a key word? Separate, a word problem in which the whole is given and one part is taken away. Oops, there we go, another key word. Change, a word problem in which the beginning part or whole or middle part is unknown, and then a word problem with 2 quantities and a difference between the quantities. Those are essential elements of the problem types of word. So now, if we were to actually teach those elements explicitly and very directly to the individual, power there. Now, of course, keywords that go along with it, as we were just highlighting a moment ago. Let's take a look at a strategy that helps with an element of that. So this strategy is a scene investigator, or math scene investigator, if you want to call it. But basically, I'm teaching an individual 3 steps. So the first step is that they need to read the problem, of course. They need to underline the question in the unit and then circle what they think is the important information and cross out distractible information. So I'm teaching them an explicit strategy, and of course would have to help them with the language aspect of what's relevant and irrelevant, or what's important or distractible. Step 2, we need to write the equation. Well, by going up to step 1 and circling and underlining, hopefully the equation, especially if we work with the keywords, we'll be able to get the keywords out, the equation out. And then drawing a picture, as we just mentioned, is an element of this that can have a lot of power in understanding, again, how to solve. And of course, we want to back up and make sure we've done the right way. And so we have the correct answer. And we can double check and we can use different language, or step 3 can be a bit modified depending upon the complexity of the problem. Let's take a look at it in terms of day 1, day 2. So day 1, we have the students basically complete the actions identified, as I mentioned a moment ago in step 1, right? And then we have them continue to practice writing the equation. Now I'm going to give you an example here in just a moment. Now, here we go. It's day 2. We take a look at students first review the first 2 steps, right? And then they check their work, and then teacher has student read the question, determine if the question was answered. So this is really addressing the language base of the word problem. It's getting at the heart of the challenge, and it's doing it so in a way from a reading perspective to be able to get to the math equation. Very, very relevant, very, very explicit, very, very necessary, and actually it's going to go a long way when the problems get more complex. So here's a visualization. So this is something we could put up on our I could have a cheat sheet, I could have my notebook, I could have up in the room I'm working in, something that's visual to say, okay, this is what I need to do in terms of the steps. And then day 2, my steps, of course, go along here. Now, I've given you this visual. I got this out of a study, actually. And the reason I'm giving you this visual is the visualization, what I'm going to mention here in just a moment, of being able to pull information out. It's very, very relevant. We'll probably get to that to the second presentation. But anyways, that relevancy of being able to design and pull that information out. Now, there's a number of different strategies that are research-based that go along with problem-solving mathematics. Their metacognitive strategies is how they're grouped. It's a nice piece from the Florida Department of Education that I'll give a link to as a resource if you guys want to look at it in greater detail. But let me pull out the 4 primary steps of that. Now, with step number 1 is this idea of understanding the problem. And I have a number of activities this week that try to pull out information from drawing to visualization to schemas to the keywords that pull out an understanding of the problem. Now, these are all different types of strategies, and again, this report I mentioned will pull out these strategies. The strategies aren't necessarily technology-based, but again, some of them you can do that in respect to how you construct things, and those I'm going to give you a few examples with the activities. Step number 2 is you devise a plan to solve the problem. So again, think about some strategies. And I've offered a couple strategies already, and we'll practice a few more as we go along. Now, there's a host of different ways of doing this, and again, the report I offered gets into, these are more things we need to teach and potentially more face-to-face solutions, but I want to make you aware of them and reinforce some of them through our activity. Now, step 3, implementing a solution plan, goes back to, in a way, that mystery, kind of solving the element, and that, okay, so we're going to have actual specific steps we're going to follow. We're going to follow that based on what we did in step 1, in terms of pulling out that information. And then from that, solve the problem. Once we've solved the problem, we're going to follow up and look back. We're going to check, and there's steps to do that as well. That's basic, of course, what we do for a lot of math problems. What I wanted to share with you is this report offers a number of different steps from a strategy perspective to be able to implement. Now, the activity, I'm going to take a break here, the activity to me is looking at some of these strategies, and strategies through some of the technology that we have available for the individual to practice and process them out. Now remember, this is language-based, so an element of what we need to do is pull out the information from the language, and then of course there's an equation and operations-based, but honestly the math aspect of that is along the lines of, well, what have we taught the individual in terms of addition, multiplication, fractions, decimals, and things of that nature. Right now, the word problem, and where the word problem presents some of the most significant challenges, is the language aspect of it. All right, that's a brief overview, hopefully enough to get you started with the activity. And the second presentation, we'll get into some more specific strategies and elements that really can be used to offer further solutions, and of course then tie technology to that. I think that will bleed into our second session on this. All right, I hope this was helpful. Have a great afternoon.